oh, I need to edit my stream info. Preparing boom. Stream updated successfully, and we are live. Ladies and gentlemen, this is a very, very exciting day. So we've been spending a fair few of the last streams replicating the NBeats algorithm, but it's now time, it's well and truly time to start preparing materials for the missing notebook on the GitHub. So that's what we're going to do. We're going to clean up all of the code that's in this messy notebook, and we're going to rebuild this one from the ground up so that it's ready for the final material of the TensorFlow course. So let's do that. Let's twitch it out. Eat more nutrient-dense food for reduced hunger. Beautiful. I agree with that tweet. I'm live on Twitch. Preparing materials for time series module of my new my new TensorFlow course. Come and say hi. We'll get a little wave emoji in there. And let's go. Oh, we need the link. https www.twitch.tv/Mr. D Burke. Boom. Tweet it out. Now let's do the same for Discord. I need to get off Twitter before I get distracted. By the way, if you want to see the replays of these, you can go to the archive channel. If you just search up Daniel Burke Archive on YouTube, I'm going to like my own video. You'll get replays of all of my past streams. They're not formatted, they're just the exact thing that you see on Twitch, ripped for YouTube. But let's post this link in the Discord. Going live on Twitch. Preparing the new materials time series module of the TensorFlow course. Come and say hi. We'll get another wave emoji in there. https twitch.tv/Mr. D Burke. Wonderful. And do I have any messages that I need to? Excellent. Okay. Let's get out of here. Yo, yo, yo. Maxwell and Better, welcome. So what we're going to do is we're going to start a new notebook. And we're going to create the outline for here. And we'll go to Colab, new notebook. This is very exciting, actually. We've got enough materials to go with, and I've got a pretty great outline here already. What does the time series module need to cover? Let's do this. So how were we naming these notebooks again? 10. This is so exciting. The last module. 10 time series forecasting in TensorFlow. Boom. Okay. Time series forecasting in TensorFlow. Put a big note up the top here. Note. You watch. If you're watching this from the start, you watch how much code is left in this, how much code is in this notebook by the time we finish, because I plan on writing a lot of code today. Note, this notebook is a work in progress and will be updated continuously over the next week or so before it's ready. We go here. So this is starting from a blank notebook. And what is the date today? I think it's the 18th of May. 18th of May. See, I have a house inspection at 1:30, so I'm going to keep going until at least then. We'll see how much code. That's about 3 hours. We'll see how much we can get done before then. 18 May 2021. Let's write the goal. The goal of this notebook is to get you familiar with working with time series data. It won't cover all of the time series field, but by the end, you will get a fairly good overview of things to consider for time series problems. So outline, let's create the outline. We need to get data, a time series. We need to format the data. We also need to model data. We're going to get baseline, simple model, deep model, various sequence models. So we'll build like 5 or 6 models. Conv 1D. We'll also get simple model. Actually, the baseline can be naive forecasting. Baseline 2 can be moving average. And then we'll actually start with non-TensorFlow models first. Random forest. And this will be fully connected. Oh, fully connected random forest regressor. Can you all see this screen on this? Yo, Cass, what's good? Siobhan's, hey. I might post a photo of this on, should we start sharing this? Nah. I'll get distracted. I just want to write as much code as possible here. Sequence model, so deep model, sequence model, and then n-beats algorithm. And then we need to uncertainty estimates. We'll also want univariate time series and multivariate. So we have, this is going to be a great module actually. Multivariate, and then uncertainty estimates, and then evaluating a time series model. We're not going to be using transformers. We could use transformers, but we're not going to. They're going to be too large. This is an introductory module, so transformers could be in the extension. MSE, MAE, MSE, RMSE, etc. And then we want to introduce why forecasting is BS. Turkey problem. Open system, beware. Closed system, try it out. Like fortune telling. C, Mark. I always forget how to spell Mark's last name. Mark Safram. Mark Safram, yeah. Mark's a great follow on Twitter, as well as newsletter. I'd highly recommend. Oh, here we go. This looks like a great article by Mark. Read and write obsessively. There are no real shortcuts to producing great work. Boom. So I'm going to read that later. And I'm going to get back off Twitter. So, see Mark's tweet. I've got some notes here as well. Yo, Alex, what's happening? Yeah, that's a great newsletter, so shout out to Mark. Thank you, Pseudomaze, for sharing that. And I think that might be it for at least an introductory to time series. Oh, and then of course we need exercises and extra curriculum. So I've got an idea for the data set. So we could do Bitcoin's price history. And then for multivariate, we could do Bitcoin's price history plus block size. So that'll add in an extra variate. Is it the best example? Maybe, maybe not. Doesn't matter. It's just that it's easily available. It will be a relatively toy problem because as we'll see, why forecasting is BS later on. Might not be this stream that we'll get to that, but we're definitely going to get some data ready. Format data. We also need to turn data into a windowed data set. So I want to get some links down here. Which article was that? Diagnosing training curves? Cass, what were you talking about there? Did we mention that? Did we go through that yesterday? We've been through a lot. We've done a lot of coding over the last few days. And beats algorithm. I'm just going to get some links here. Forecasting is BS by Nassim Taleb. This is a great video. Yes, we did read through this the other day. Yeah, so if these two are separate, that's what you got to watch out for. What I was really going for is trying to reduce these bumps. Yeah, so that's a really good learning curve. They're nice and close. We can come back to that later. Let's get rid of some tabs because my computer is crying at the moment. I'll just get rid of all of these tabs. And if we need them, we can also just add them back more. Yes. Thank you, Pseudomaze. Pseudomaze just linked in this tweet. This is exactly what I'm talking about. So we're actually going to see, I just want you to be very wary of the fact that if we predict Bitcoin's price, it's basically like this. Time series forecasting, predicting stock price using an LSTM model. It's basically like palm reading. So this is not financial advice. I don't know why I have to make that disclaimer, but I've seen people do it all the time. You're smart enough to realize, or as you'll see, I'll just demonstrate this later on. We probably won't get to that this stream, but certainly in another stream, we'll get to that. But this is, where we go here. This is the tweet I'm talking about. So, yeah, I won't allude to that too much later. But basically, the difference, I can explain it quite quickly, is in an open system, such as a market, where you have a stock market, you have almost an infinite number of variables. Your model, the chances of your model being able to use all of those variables to predict one variable is very, extremely low. You basically have to reinvent the entire world in a model for the model to be able to predict tomorrow's stock price. You'll see when we do a baseline estimate, the naive forecasting, which means predicting yesterday's stock price as tomorrow's stock price, is probably going to be well and truly the best model that we'll be able to build for any time series forecasting for stock prices. Whereas in a closed system, right, so that's an open system. Now, you know examples of this very clearly. Think of the weather forecast. How often is a weather forecast incorrect? Now, the reason being is because a weather forecast has so many variables to include. Even the most sophisticated modeling systems in the world get the weather wrong. They can't predict. My heuristic of my naive forecast of looking outside and saying that it's sunny is just as good as if not better, as a weather forecast. Now, in a closed system, such as like a computer network or something like that, where you can control many of the variables, such as the number of computers that you have, the number of, well, maybe you can't control the number of users, but you can control a lot of things in a closed system. That's when you might want to try out time series forecasting. So in an open system, take every prediction with a grain of salt. In a closed system, you may be able to use them a lot more. I know for a fact, like DeepMind, Google power usage. So this is like a closed system, right? DeepMind AI reduces Google's data center cooling bill by 40%. How do they do that? Well, they use some sort of forecasting to predict where to improve power resources. But as you can see, Google probably built this from the ground up, so they know what goes into this system. It's a closed system, whereas a market or the weather is an open system. So just keep that in mind. I hope those examples make sense. Exercise and extra curriculum. We want the time series book. It's a great book. Yeah, O-text. I'm not sure why the title is called this. Oops. Why is this not copying the link? Yeah, this book. This is in R, but it's you can relate it back to Python. So there's that. Oh yeah, that's another thing we have to do for the format data. Training, test sets for time series. Oh, Pseudomaze. So, Pseudomaze says, have I considered using Obsidian MD? And you know what? I did see this. My friend Ashik sent this to me the other day. And great. I think there's a lawnmower outside my window. This looks amazing. Have you used it, Pseudomaze? Because I'm writing my notes here in Markdown, and I believe this works purely off Markdown, right? Okay, so the lawnmower is not too loud? Thank you. I'll have a look into this later on. I'll get distracted. But okay, so you recommend Obsidian? It works well with just Markdown files? Because that's, at the end of the day, I've tried different note-taking apps, but I keep coming back to just using pure text files. Text wins over the long term. Text is Lindy. I'm sure a computer in 50 years will be able to open a .txt file. Okay, I think that's what we want. Yeah, we'll get the types of uncertainty in here. Coconut. This is epistemic. And we want subway uncertainty, which is aleatory. Okay, I think that is well and truly enough to cover a baseline of time series. There can be plenty of extra curriculum, so let's now write these into headings. To do. And this is a bit of insight into how I make materials for my course. So basically I spend like at least 2 to 3 weeks making, or at least researching things for myself, like you've seen in the NBeats replication. And then I work on a project, and now we're putting it into a structured material. Format data, and then within format data, we want these. You let me know if the lawnmower is getting too loud. I don't think it should be around for too long. Cass, oh no, Alex asks, what's Lindy? Can someone send a link to Alex about what Lindy is? I don't want to get distracted, but okay, I'll explain it. Here's how I understand Lindy, Alex. If it's using time as a filter, so if something has been around for a long time, chances are that it will continue to be around for a long time. In terms of a text file, a .txt or a .markdown file, that these types of files have been around since the dawn of computing, so chances are they will still be around in 40 years' time. So that's the Lindy effect. You use time as a filter. What else do we want to do? I'm going to get this into another document. That way, we can double window it. But if you want a good introduction to Lindy, look up Lindy Man and then just go to his Substack, and you'll find some great information there. Thank you for all the subscriptions, Supernova. I appreciate it. Time series. Lindy Man on Twitter will have the best introduction to Lindy. After all, it is the Lindy Man. I don't like that Colab just didn't give me any formatting for that. Well, that's shocking. latex support. Beautiful. Okay, so these are the sections that it's going to be. Format data. This is mostly concerned with inputs and outputs. We actually need what is a time series problem. There's forecasting, and there's also classification. We'll put that at the start, actually. Forecasting. Classification. What else do we want to do? We want some uncertainty estimates. So we're right back where we were in one of the first streams. Just outlining the materials, but since that stream, I've learned a lot. So this is why we're going to cement my own knowledge via teaching it, as well as create materials for others to learn more. Okay, there we go. We've got an outline. Supernova, you're a legend. Thank you, I appreciate it. I'm so new to I'm still new to Twitch, so I don't know how all this like subscribing and following works. Oh, another one. You're too generous. Okay, so then we need to format the data. After we formatted the data, we will... These are some regular steps that we're going to do. To do series model. This can actually be TK. This can be a function for each model. Compares predictions to ground truth. Model data, and we said we wanted to build a number of models. I think that is well and truly enough, just to get an overview. Or actually, there's a great article on comparing different forecasting methods. I found that comparing different forecasting methods towards data science. Okay, so they use AR. All these for, what do these stand for? Autoregressive. Moving average. ARIMA. SARIMA. So these can probably be extensions. Wow, we're getting a lot of subscribers, and thank you so much. Oh, thank you, Alex, for letting me know. Good to hear that you got your certification after passing it. Holy crap. Subscriptions are going wild. Thank you, team. I really appreciate it. I plan on doing a lot more live streams because I feel like it's a lot more akin to how things get done or actually get done versus like of course there's a time and a place for an edited YouTube video, but in terms of like just raw material, this is how it all happens. So yeah, if you have any ideas for things you'd like to go through, I have a fairly large project I'm going to be working on after I finish this course. So I'm probably going to be just streaming materials for that. We'll get the resources in here. And also, what we could do is TK inject a turkey problem piece of data into the model and see how it affects it. E.g., one data point that's 10x or even more, 50x of an outlier. Turkey problem, and then we also need, we'll leave us some space there, and this can be exercises and extra curriculum. Okay, so we've got our skeleton notebook. This is very exciting. So let's save this to the GitHub. Okay, so these are all lowercase. I'm going to lowercase that. Wow, thank you everyone for the kind words. I appreciate that. Cass gets a lot of work done. Alex enjoys the experience of live. Supernova enjoys working through different problems, being able to interact, navigate through it all, organic and interactive. Oh, thank you guys. So yeah, there's plenty more to come. I'm still working out the right balance of sometimes, of course there's going to be times where I can't live stream because I need to just concentrate on a problem and can't interact. But while I'm making these materials, it also helps me to explain different things, you know. Commit message is add shell notebook for time series module. Work in progress. Add shell notebook for time series module, work in progress. So if we create a copy in GitHub, we now officially have time series. Beautiful. Okay, so let's now write some more code. Okay, so we're going to get data. Let's predict the price of Bitcoin. Note, this is not financial advice. As you'll see, time series forecasting for stock market prices is actually quite terrible. See this tweet for reference. This is going to be like an anti-module, right? It will teach the fundamentals of time series forecasting, but it will also teach how to think about where time series forecasting should and shouldn't be used. So if you ever see someone, where's Mark's tweet? let's debunk. Because negative knowledge is actually more powerful than positive knowledge. So that's what this whole notebook could be. This could be negative knowledge about time series forecasting for univariate data. We've got to get Bitcoin, so we've got to import with pandas. And I need to also teach importing with CSV, with Python CSV. So let's find the Bitcoin price. This will actually be pretty good because I think Bitcoin actually had some like a fairly significant up and down movement over the past couple of days. Look at this, beautiful. So this has got some great movement. We've got, if we look at the last 3 months, let's import this. Export data, CSV. See, this is why we're doing Bitcoin, because it's easy to get a data set. I've already got some data sets from Bitcoin. There we go, Bitcoin USD 2013 10/01. So since the inception, so 10, what's that? This is US dates. So this is, oh no, it's the 1st of October 2013 to today, 18th of May 2021. So I'm going to just add this to Dropbox. Where's mine? Let me know if the lawnmower is getting too loud. I can close my window. I'll just sweat it out for a bit. What's better TV? Link me better TV and, or tell me what better TTV is. Data to do upload to GCP, upload to Google Storage. Right now I'll just import it as a CSV. I think pandas can actually just import directly from CSV, or we could just store this on GitHub. It's only a CSV file, so it's not going to be that big. df equals pd.read CSV. Let's see what happens if we just pass this link. Hey, Day Adam, what's good? About to do your goddamn taxes. I just did my taxes for the last 3 months. What's this? Let's see what this CSV file looks like. Okay, this is better TV. All right, I'm going to add this later. So add Better TTV to stream. Look at this is my to-do for the week. Stretches every day because I'm injured. Walk, mobility. And Monday to Friday is time series material making. So that's my extent of planning. I'll go through this later. But, okay, so here we go. We've got some Bitcoin data. Let's see how we can pass the dates. English to Australian translator. Oh yeah, I do want these tweets. I mean, emotes. Okay, there is a past dates parameter here that we want to use. Past dates. Do I just say true? Okay, so if true, pass the index. List or of int or names. So I need to pass it the column. So it's column 1. Okay, beautiful. So pass the date column. Tell pandas column 1 is a date time. So that's cool. I wonder if we didn't have past dates and we got df info, does it read it in as a date column? No, it doesn't. So if we pass the dates, I don't think we actually need to, because we can just use this later. So look at that. If you bought Bitcoin in 2013, it would have been $123, and now it's 43,000. So what's that? 4,000x return. 350. Sorry, I had a 400x return, not 4,000. Close enough. Now, if we want the date as the time steps, so we also just want the closing price. So let's just reduce this column, this data frame, down to date and closing price. So Bitcoin prices equals DF. I'm going to copy this column name. Yeah, okay. So there we go. Now if we plot this, what does this look like? What's happened here? The date column actually doesn't matter because we're going to be using time steps. Or it will matter later on when we bring in. Yeah, so there we go. We've replicated the plot. But we all know it would be much better if we had the dates along the bottom. But we also know that you can spend up to 3 hours on Matplotlib just customizing one thing, which is not really what we want to do. Okay, so what's happening here? View limit. Is there something special we have to do to plot Matplotlib plot date column? So it might not have passed our date correctly. Past dates. Okay, so that's probably a good idea. Index column is date. You know what? If we go, did the data types follow this? Okay, it did follow. Pseudomaze, thank you for that. I'm going to rearrange this plot. So past dates. Let's make the date column the index column. Beautiful. So then we just want Bitcoin prices. We just want the closing price. Now what if we just plot? There we go. Okay, beautiful. So we've got our dates, we've got our price. As you'll see, so time series, we basically just want to use the past to predict the future. So we could use everything up to 2021 to predict 2021. But with stock price predicting, if you're a trader, you probably want to predict tomorrow's price. If you're a holder, you probably want to predict 2030's price. So DF info, Bitcoin prices. Only want closing price. Past dates and set date column to index. So now let's see how we can do it with Python, just the CSV. So with open, we need the path. As F. What's the Python CSV reader? I come back to this guide almost every time. Real Python. I like this guide. Yeah, CSV reader. Let's just try something like this. Reader. CSV Reader. Did I just mess up that again? .reader. Wait. Oh, import CSV. That's what I'm missing. Are you catching this? See how poor my CSV reading skills are? CSV Reader. There we go. We got there. This is going to look disgusting. Okay. Cass, we could just use pandas, but I just want to show two ways of doing the same thing. I'll be back in a sec. I need to go bathroom and get a drink. That the lawnmower is definitely not too loud. Today's stream is sponsored by San Pellegrino. Not really, but if someone from San Pellegrino is watching this, have an unlimited supply of this and I will place your product in the stream. Only the glass bottles though. No plastic San Pellegrino bottles. It tastes better out of the glass. Don't ask me why, it just does. That's the dream, okay team? You want to get sponsored by San Pellegrino, and I'm new to this Twitch game, so if my stream improves, we might be able to reach enough subscribers to just pay for the projects that I'd like to work on, then it's win-win. Okay, now, Alex has sent me a tweet from TensorFlow, and here we go. Next generation pose detection with MoveNet and TensorFlow JS. This is awesome. Oh my gosh. This could be a cool project. Oh my gosh, we could build ML Fit. Alright, I'm going to look into this later. We could build ML Fit. That would be a cool stream. Look at this. If we look up Daniel Burke ML Fit, ML Fit.
So to celebrate the launch of my new
Look, ML Fit. We could build this.
say we're training for 2 epochs, how many push-ups is that?
Get it to monitor the movement. That's an idea for a future stream. Now let's continue with this. ML Fit, baby. Hey, well, it would be all open source code, so Alex, you could take it. I'll put it all on GitHub. We'll put it on GitHub. We'll make it as a team. Let's. Do they just append these to a list? I prefer pandas, you know why? Because it's visual. So if we wanted these... we could make a dates array. So if we did time steps equals empty list, and then BTC price equals list, we could just append here. Equals line time steps dot append line index 1, get the dates. We want to skip the first line though, and then we will also get the closing price, which is 2. But we want to skip the first line. How do we do that? Line count. You can actually skip the first line in, I think there's, what's the Pythonic way to skip the first line? How to skip first line in CSV. I've seen this. Next. Yeah, beautiful. Thank you, Alex. Cass, did you mean the link to ML Fit? If you just search Daniel Burke ML Fit, it should come up. This is ML Fit. That's actually a sick application, ML Fit. Yeah, I think this is it. And then we go... Okay. And then if we plot from CSV, plt.plot, let's get time steps will be on the X, and then BTC will be on the Y. Plot.x label. Oh, there's no underscore, is there? Hold on. What is happening here? Colab has crapped itself. You know what's wrong here? The time steps are not passed as a date. Yeah, see here. That's why it's taking so long. If we just plot a range, should be quicker. Len. Why is this plot taking so long? I think my Colab instance is crapped itself. Is that why? Surely not. This is not even that big a plot, matplotlib. What if I turn this into MP array? There has got to be something wrong with matplotlib. It worked fine there. How do we turn Python turn array into datetime? Convert numpy array. How, I don't understand how that happened. This is just an array of numbers. and it plotted it like crazy. Huh. Oh, thank you, Alex. I've got the date times up here for pandas. I'm now trying to convert. There we go, strip time. It's year, month, day. So we get to learn how to work with datetimes. Time steps, we'll turn this into a datetime string from time, and the format is going to be year, month, day. Why is this not working? Is this for real? I'm passing it a string. String pass time. Oh. But I don't want that. Strip time. Now I want to format this . Now if I do datetime dot string format time, so does this make sense? Who's more experienced with datetimes than me? So I have to rip the date time from the string, and then if I want to format it into a string, but then if I get the data type, this doesn't make sense, does it? It's a string. So I've just converted it back to a string. Can matplotlib plot dates? Date times? Okay, so it can plot dates. But what is going on here? Oh, because these are all strings. Derp. Who didn't catch that? We'll convert these to floats. Wow. Just with a single data type error, we were trying to plot strings. Have a go at that. That is it. All right, pretend you didn't see that on stream. Nobody saw that. Absolutely nobody saw that. Just took me 20 minutes to realize that I was trying to plot strings. Okay, everyone. We just, yeah, Yeah. All right. So now we've got CSVs. Get the dates, as float. So now we can do CSV and pandas. I prefer pandas because, as you see, that I didn't do very well there, did I? Okay, this is as raw as it gets. Okay, so turn data into a window data set. We need training and test sets for time series. Let's create a training and test set. So that's worth a highlight of this stream is when we finally plotted our data. Let alone building a single model yet. Let's just get the data plotted. Create for time series. Note, cannot do random split. Time series will buckle under this using future values in the past. Need to make train set values from past, test set values from future. You're totally right, Alex. Everyone is still learning too. Let's wrong way to make train test sets for time series. So let's from sklearn.model selection, we'll do the wrong way first. Import train test split, and we want xtrain xtest ytrain ytest equals train test split, and we want to split x is the dates, so we want, what's our Bitcoin data frame called? Bitcoin prices. Date, oh no, dot index. Is that correct? If we look up Bitcoin prices, what format is our? Can we get this as an ND array? I wonder if it'll just take that, if it will automatically convert it into yeah, I kind of jinx myself saying that you can usually spend hours on a graph. Okay. I want to rename this column because closing price I'm not a fan of. Why is it telling me? Does that do that in place? No. Is there a rename method? Thank you, Maxwell. Rename. Ah, there we go. What was it again? Dictionary. This gonna work? It doesn't take columns. Did I spell columns wrong? Columns dot rename. Huh? Because this is a series, isn't it? There we go. Okay, friends. We have the price you pay for having communicative data. Why can't I do this as a... There we go. Hey, Samantha, what's good? All right, so we're on. let's now make a data set. At least one array required as input. Yeah, so I think this is 2 array. Or is it dot array? Array. Yeah, so that really doesn't turn it into an array, does it? Bitcoin prices, price. Is it 2 array? Array. To NumPy. There. One of the methods. And then do we get... Oh. Your 4-week trial of Bartender has finished. I have bought Bartender. And Bitcoin prices, how do we turn the index into an array? At least one array required as input. They are both arrays, my friend. This is an array. Oh, you know what? This actually doesn't have parameters. I keep forgetting this. Yeah, okay. I always forget that. Let's plot wrong. So plt.figure. So we'll get the train data and the test. Holy goodness, what a plot. You know why this is not working? Because it is a line plot. Again, San Pellegrino. If you want to sponsor the channel, you know where to find me. I live on the internet. So this looks like a drawing a 3-year-old might do, but we actually need to convert this into a scatter plot. Whoo! And we need the size, which is, I believe, the S param. Let's make these dots smaller. Okay, yeah, so do you see now why this is wrong? Because what are we trying to do? We're trying to use the training data to predict the test data, but this is a time series. So we can't have, let's get a legend here. We can't have test samples scattered throughout the training samples for time series. So how do we fix this? Well, we can fix it via cutting an index here, and we'll use this part for the training data and this part for the test data. So this is the wrong way to do it. Abstract art. It's beautiful. The price of Bitcoin. Okay. So we want temporally based time series splits. So split size equals len. Why don't we get them in arrays? So we can just use that later. Get Bitcoin data array. BTC dates equals, should we call it that, or should we call it time steps? Let's call it time steps. Time steps, and then prices. 2 simple values. Bitcoin index to NumPy. I might make this into a YouTube video as well. Once it's clean, and then show the dangers of predicting Bitcoin price with machine learning. Okay, so now we've got 2 arrays, and we can sub these out for time steps and prices. Wrong. Wrong. So split size is, we want 08, let's get 80% int. %, train, 20% test. So 08 times len of prices. And then the split size is going to be what? About 2,229? Yeah, okay. So we have 2,000, and this is another thing with time series. I'm going to write this down. So this is a to-do for later. To-do, note, time series, forecasting can often have many less data points than traditional deep learning projects. E.g., the entire history of BTC daily price data equals only 3,000 steps. 3,000 samples. Versus In a previous project in this course, we've worked on a project with 100,000 data points, and even that is quite small compared to some of the large data sets. So split size, we'll get that. Now let's create train data splits. So we want xtrain equals, that's going to be the dates, so that's the time steps, and we want up to the split size, and we also, what did I just do there? Chrome settings, hello. Sorry, don't want you. And we also want prices up to the split size. We can also create test data splits, x test, y test equals time steps. We want the split size and beyond. And for the prices, we want the same thing. And then we'll get the shapes. Shape, x test dot shape, y train dot shape, y test dot shape. And then we go plot correctly made splits. But how could we, to make a prediction for tomorrow's price, we could use the entire I'm going to put this for to do later. To do, use entire time series to predict next step, compare to actual data, e.g. revisit the prices in 1 week and see how the model goes. Oh, this will be cool for a follow-up stream. Yes. So, start date could be 18th May 2021. End date is 25 May 21. Revisit the updated prices here and see how wrong the model is. Okay, that would be cool to just revisit it, because that's the thing with time series. For every new prediction you make, you need to retrain a model. So if new data came in tomorrow and we wanted to predict for the day after, well, we'd have to retrain a model on that new data point that came in, make a prediction, and do the same every single time. So now let's plot the correctly made splits. We'll get this. All right. So you see here, this is what we're trying to do. Use this data to predict this data. This is going to be actually quite hilarious, because I don't think our model's going to do very well at all. Right, so this is much better. Much better than before. But you see, you can already start to see, is that how can a univariate model incorporate this large jump? We've got a jump here of like 5x off what it is. We'll find out. So it doesn't have, the training sample doesn't have these steps here that are continually increasing. So let's now make a naive forecast to begin with. And then I'm going to also have another to do here. To do what kind of steps should we predict, e.g. 80%, e.g. 80-20 split. Is that realistic? You may want to use all of the data up until the last week. Convex Optimization by Stephen Boyd. Pseudo Maze is asking, have I studied it? No, I haven't. I've never heard of it. Maybe I have, maybe I haven't. Convex Optimization. MP hard. What kind of problems would I want to use this for? Oh, this looks like gradient descent. Oh, okay. I see. So gradient descent is the opposite. This would be gradient ascent. Am I right? Wait. This is just gradient descent? Is this a fancy name for gradient descent? Oh, okay. In that case, yes, I've studied gradient descent. Here we go. You're trying to find f of x, minimize f of x. Ah, I see what you mean. All right. Well, let's keep pushing forward with what we're doing. So, yeah, and Alex is right in terms of, because time series is rapidly changing, this kind of doesn't make sense to use this much of a split. So this is where intuition can come into it. If we look at the training and test sets of evaluating a forecast accuracy, they've got the size of a test set is typically about 20% of the total sample. Although this value, let's read what this says. Depends on how long the sample is and how far ahead you want to forecast. The test set should ideally be as large as the maximum forecast horizon required. The following points should be noted. Window. Yeah, so we need to create a windowed data set. Yeah, so these are probably the error formats that we're going to take. Error. This is a great explanation of mean absolute percentage error. Looks like a really good, check this out if you want a good resource for measuring the performance of a forecast. So with that being said, that would mean that we need to later on probably create a variable for building a data set that creates a test set that is the size of the forecasting horizon that we'd like to predict. So say we wanted to predict a week into the future, our test set would have to be at least a week worth of data. We'll find this out empirically. I'll be back again. Okay, now let's build a naive forecast. Naive forecast equals use the previous Oh, thank you, Pseudomaze. I appreciate that. If you have like a YouTube video on convex optimization that you'd recommend, I'll check that out. Naive forecast. Use the previous time step to predict the next time step. Fancy math. So that would be LaTeX. We want hat. Is this not going to turn into math collab? Come on. There we go. Y hat equals y hat t I'm getting better at LaTeX, people. Equals, oh no, we actually want those dollar signs. Dollar bills, y'all. Y hat t equals y and then underscore t minus 1. That makes sense? Okay, so to do, we want make evaluation function for various metrics. Thank you very much. Whoa. So we've got convex. He suggested students use Python at 2008. And then edX also has let's look up Eli 5. Approach the best solution giving a space of probabilities. This is exactly what you just said. Think of a cereal bowl. The bowl has the lowest point, the bottom. The bowl represents many solutions to a given problem. So you search many points in the bowl until you reach the bottom. That bottom is the optimal solution, just like gradient descent. This is great. Thank you. edX. I'm going to also save this. ML. Okay. Back to the code. Yes, you're completely correct, Alex. That's the naive forecast. We'll see it right now. So we have y test, which is some array of numbers. So we're trying to predict on the test data set, of course. And so y test is the ground truth, but y forecast, so the naive forecast, so naive forecast equals y test everything up to -1. No, sorry. Everything from 1 onward. No, you're using the next time step. So if t is 1 and we have this, the forecast equals t minus 1, which would be this. Yeah, so the naive forecast is up to -1. But then we'd have to create this y test for 1 onwards to compare. Does that make sense? So there's the naive forecast already made. So plot naive forecast. You'll find that this is probably, we won't be able to beat this. X test. Boom, boom, boom. But now let's zoom in. So if we were to zoom in on this, why don't we just not plot the training data? Wonderful. So see how the naive forecast is just, I think we can get away with these as being lines now. See how the naive forecast just follows the line. It's slightly shifted to it's one time step to the right. Let's get the last 200 values. Maybe even over the last 100 time steps. Yeah, okay, so that's plot naive forecast zoomed in. So does this make sense? The naive forecast is probably going to be our best performing model. And let's functionize this. Depth plot zoomed in, and we want, what can we do for this? I'm going to just put new preds here. We just got a little helper function here for later on when we plot some models. Okay, wonderful. So now let's create evaluation. We've actually already got this. So I'm just going to bring out this. Maybe this function won't work because we don't have. Let's see what happens. Yeah, so we get a fairly large MAE, massive MSE. Soya says, which is more easy to use, PyTorch or TensorFlow? I have more experience with TensorFlow, though they are quite similar. So when we window a data set, let's window a data set. Why do we window? Thank you, Suya. I really appreciate it. So this will be model 0, naive forecast. Moving average. Can we build a moving average? Let's see what that is. There's a leaf blower going outside my house, so let me know if that's too loud, by the way. I wonder... So now let's see if we can window a data set. So we want to... How can we do this? So what do we have at the moment? We have X train, Y train, and we also have X test, Y test. I only want to see the first 10 of these. Come on. So Y train. So I want hey, nice one, Cass. I'm finishing the taxes. So we want something like this. How can we get it? We can use TensorFlow to window. Let's look up create window data set in Python. Sliding window vectorization with NumPy, boom. Multivariate time series. Yeah, so this is a good example of a closed system. This is a simple power system with 3 generators, 9 buses, and 9 lines. This is good. This is a great article, actually. Yeah, that's what we want. So start with an empty list. This is a naive window extractor. Yeah, we can definitely do this with indexing. Oh, that's cool. We can index any 2D submatrix of rows of a 2D matrix using a 2D matrix of integer slices. Oh my goodness. First we create a matrix I, which is a 3x4 matrix of integers. Then we index multiple rows of X together using NumPy's fancy indexing, giving us a 3D matrix. Okay, that's where they get that. Wonderful. The first index of the output of the 3D matrix is the 2D matrix if we use trick number 1 on matrix X with the indices there. This is a good article. Alex is asking, would I do a recap stream for I/O similarly to the way I did for NVIDIA? Potentially, if there's some cool things that I find in I/O. I've got about 3 videos lined up. This is a great article. Give that a bunch of claps. So pass it in an array. Pass it in clearing time index. So the window size is going to be K. Clearing time is C. Max time is T. And a sub window size of K. So max time T. Yo, Hamza, what's good? What's the difference between static and dynamic computer vision? I'm not sure. What's the context? Where are you asking that question from? So let's see what this does. I have to leave. Let me set a timer because I have to leave in 25 minutes. Is that enough time for me to get out of here? I hope so. I don't want to be late, so make it 20 minutes. We've got 20 minutes left in this stream. Let's see if we can create a windowed data set. Xrand equals Okay, so we've got that. This is not what I want. Turn univariate time series into windowed dataset in Python. Ah, I think this uses a This is good. Why train? This is what I want. let's look at our Bitcoin prices in... So I can shift it like that, but why am I being... Why is my brain not giving me... Let's do it quick and dirty way. Or try to. There has to be some fancy indexing technique. So for element in Y train, NumPy split array into groups of 10. Oh, okay. So that only splits it into 10 arrays, but I wanted to split it into length 10 arrays. split it into len. There we go. Okay. So we've now got a stack so this can be our So now we have 220 arrays of 10 window size. Now to create the labels, we want the last step of the previous array as its label. So this one's label would be the first value of the next array. Hey, John Alex XB, SB, welcome to the stream. So then if we had window x1, yeah, so we want to use these 10 steps to predict this next step. We're onto something here. So the next thing we want to do, how much time do I have left before I have to go? 2 minutes, okay. We'll write down what we want to do next. Next is get labels from above array. Take the first element of the next element to create the windowed data set. Can a lambda function or fancy indexing be used here? Okay, so in this stream, we made the outline for the forecasting notebook. So I'm going to save this into GitHub. Update notebook with outline and getting data. Next, formatting data. So I'm going to put this into the TensorFlow course and come back to this later. How many lines did we get with that? I'd keep going here, except I need to go look at a house. There we go. Okay, so we got 1,800 lines. A lot of it's going to be, oh, there's the timer. Perfect timing. A lot of it's going to be markdown and text, but we did get a fair bit of code there. I'm going to keep going with this in the next stream. But otherwise, thank you for tuning in. Whatever you're up to, keep learning, keep creating, and I'll see you in the next stream.